200 million rats represent the scale of a biological challenge currently affecting both dense urban centers and vast agricultural territories across the country. This staggering population is responsible for an annual economic deficit of approximately 45 billion US dollars. Why did traditional localized methods fail to contain such a massive infestation? A few traps placed in domestic corners or residential yards only address the surface of the problem. In reality, millions of hectares of vital farmland have transformed into hidden battlegrounds where the survival of crops is constantly at risk. The scale of the destruction once suggested that the rodent population was an unsolvable technical and logistical crisis. But then, a quiet turning point emerged in the management strategy. Coordinated trapping campaigns replaced the practice of fighting rodents on an individual, isolated basis. It is visible how these large-scale operations utilize synchronized equipment and systematic placement across entire regions to intercept the pests. At first glance, the task of clearing millions of hectares seems impossible, but in reality, the transition to industrial-level management changed the outcome. The process is only gaining momentum as the focus shifts from simple eradication to resource recovery. What was previously categorized as a terrifying threat to every harvest season gradually shifted into a different classification. One can notice how the captured biomass is diverted into a structured processing chain. This allowed the country to transform a biological liability into a source of valuable economic food products through strictly controlled technical stages. The equipment gradually processes the intake, ensuring that every ton of formerly destructive material serves a secondary industrial purpose. Everything only gets more complicated as the logistics of collection and sanitation are refined to meet national standards. The camera glides along the rows of specialized collection units that now define the modern agricultural landscape. This transformation marks a departure from reactive pest control toward a proactive, integrated economic model. From here, the management of biological threats moves into a phase of high-efficiency utilization. Thus, a significant environmental and financial drain is converted into a stable production cycle. 60 different species of rodents currently reside in close proximity to human settlements across the globe. Why have these creatures remained an inseparable part of urban life since the 15th century? Merchant ships originally carried them across the Atlantic and Pacific Oceans, allowing them to disembark at every newly constructed port and trade hub. But the true expansion occurred as grain warehouses multiplied and subterranean sewer networks began to take shape beneath the streets. The process of colonization is only gaining momentum. One can notice how these rodents have claimed the underground infrastructure as their primary territory. Their survival is not dictated by physical strength or massive size, but rather by an unmatched biological characteristic. Under favorable environmental conditions, one single pair of rats is capable of producing between 80 and 100 offspring within a span of just 1 year. It only looks obvious that traps could solve the problem, but in reality, the sheer speed of their reproduction creates a cycle of exponential growth that mechanical interventions cannot counteract. The next generations immediately enter the reproductive phase, ensuring the population expands faster than it can be removed. This creates a hidden empire beneath the surface. In nations with high population centers like India, China, and the United States, tens of millions of rats occupy every concealed corner of the urban landscape. It is visible how the density of the human population directly influences the expansion of this hidden network. More people mean a more abundant food supply and a more intricate maze of tunnels and pipes for the colonies to inhabit. Everything only gets more complicated as cities grow larger and deeper into the earth. Rats do not arrive as a sudden localized disaster, but as a persistent biological presence integrated into the city structure. Because of this complex relationship between food availability and underground shelter, complete control has remained impossible for several centuries. The material conditions of the modern city continue to support this hidden population without interruption. $1.3 billion is the annual cost of vehicle damage caused by rodents, according to insurance industry estimates in the United States of America. Why are these animals so attracted to the internal components of modern machinery? At first glance, the presence of rats in a warehouse or garage appears as nothing more than a few superficial bite marks on packaging or stored items. But in reality, the primary danger remains hidden from view until a catastrophic failure occurs. In urban environments, rats are drawn specifically to plastic-coated electrical wires because these materials often contain organic compounds that trigger a biological urge urge to chew. It only looks obvious that a rat is simply looking for food. In San Jose, California, during the year 2015, firefighters confirmed that a house fire originated within a wall where rats had stripped the electrical wiring completely bare. The homeowner remained entirely unaware of the lethal hazard until smoke began rising from the ground floor in the middle of the night. One can notice how a single short circuit caused by exposed copper leads to the rapid ignition of structural materials. The process is only gaining momentum as these incidents become more frequent in densely populated zones. Tens of thousands of incidents related to rodents gnawing on civil infrastructure are recorded every 12 months by urban management authorities in China. They dig through gardens, compromise complex drainage systems, and cause the ground to subside around residential complexes. It is visible how the soil structure weakens when tunnels collapse under the weight of sidewalks and foundations. But this is just the beginning of the structural threat. Factory and warehouse fires linked to destroyed electrical grids are reported across many cities in China with increasing regularity. The risk of a rapid-fire spread reaches its peak during the dry season, when industrial materials are most combustible. Sensor systems and critical control lines are often the first components to fail under the pressure of constant gnawing. The equipment gradually loses its ability to regulate voltage or detect heat as the protective insulation is removed bit by bit. Everything only gets more complicated when the damage is buried deep within the concrete and steel of a city. Because these rodents are persistent, even the most robust infrastructure remains vulnerable to their biological habits. Beyond the destruction of wiring, the physical displacement of Earth leads to long-term stability issues for public roads and private property. The transition to the next level of urban damage occurs when these small-scale actions accumulate into systemic failures of the power grid. Thus, the quiet movement of rodents through the hidden corridors of the city creates a continuous cycle of unseen destruction. 75 to 200 million people in Europe perished during the 14th century due to the rapid spread of the bacterium Yersinia pestis. Why did such a massive biological collapse occur across an entire continent? It would seem that the rats themselves were the direct instruments of death through physical contact. But without the fleas living on their bodies as primary vectors, the plague could never have decimated nearly half of the total population at that time. The real danger lies not in the physical damage caused by rodents chewing through structures, but in the biological remnants they leave behind. Droppings, urine, and parasites create a persistent invisible threat within human environments. One can notice how dust becomes a carrier for pathogens once it is contaminated by dried feces or urine. Humans do not require a direct bite to become infected, as simple contact with these contaminated surfaces is sufficient for transmission. But this is just the beginning. Economic systems, complex trade networks, and established social structures collapsed for several decades following the medieval pandemic. The process of societal decay followed the paths of merchant ships and grain wagons. It is visible how the movement of goods simultaneously acted as a delivery system for disease. Everything only gets more complicated when considering modern medical challenges. At first glance, ancient plagues seem like a relic of the past, but in reality, the biological threat has never disappeared from the modern world. Hantavirus currently maintains a fatality rate that reaches between 30 and 40% in documented cases. Furthermore, leptospirosis is transmitted through rat urine and affects more than 1 million people across the globe every single year. These numbers represent a continuous cycle of infection that begins with the presence of rodents. The process is only gaining momentum. High population density and dense transportation networks now serve as accelerators for localized outbreaks. A small infection in a single residential area can spread across a city within a few days due to continuous supply chains. It only looks obvious that isolation would stop the spread, but in reality, the speed of human connectivity outpaces traditional containment. When rodents enter these integrated human systems, the transmission of disease follows the lines of infrastructure. The global reach of modern logistics ensures that no region remains truly isolated from the risk of zoonotic transfer. Automated warehouses and shipping containers provide silent transit for carriers of bacteria and viruses. Monitoring these networks is a constant technical challenge for public health systems. The material remains a significant factor in urban planning and sanitation protocols to this day. Thus, the biological interaction between these species continues to shape the safety of human habitats. 100% of human settlements share a nearly identical reaction to the presence of rodents. One can notice how homeowners set mechanical traps inside dwellings, distribute chemical poisons around storage facilities, and seal structural cracks in walls. Why is it that these conventional measures appear to be effective only in the short term? It only looks obvious that catching a few rats and destroying localized nests solves the crisis. But in reality, the silence that returns after a several-day period is an illusion of control rather than a definitive victory. Rats do not merely possess the biological capacity to reproduce at a rapid rate. They also demonstrate the ability to learn with high efficiency. When a single individual is killed in a trap, the remaining members of the colony begin to avoid unfamiliar bait and stay away from specific coordinates where traps were previously deployed. One can notice how the colony shifts its feeding schedule to hours when human activity is at its lowest. Behavioral studies confirm that these rodents are capable of remembering specific sources of danger and transferring this survival experience to other members of the social group. The process is only gaining momentum. Population numbers may decline for a short chronological window, but the density rebounds after just a few breeding cycles. It seems simple to assume that humans have gained the upper hand, but the rodents are simply calibrating their survival strategy. Before any sense of relief can solidify, the animals have already retreated into the darkness of drainage tunnels. They move with absolute silence through irrigation ditches and concrete canals before spilling out into the vast expanses of the rice fields. Damage remains hidden until the rice begins to head and mature. It is visible how patches of the landscape are stripped bare, with stalks chewed down to the soil line, revealing the true magnitude of the biological destruction. These systemic losses eventually forced local communities to discard isolated trapping methods in favor of coordinated, large-scale collective operations covering entire agricultural zones. But this is just the beginning of the strategic shift. 30,000 hectares of rice were destroyed during the 2014 outbreak around Dongting Lake in the Hunan province. The economic losses during that single event exceeded 1,500 million yuan. Without unified action, national production can drop by millions of tons if multiple key regions suffer simultaneous attacks. For a nation that accounts for nearly 30% of the global supply, such a decline generates immediate shockwaves through the domestic distribution network. Dozens of families now work in unison rather than managing individual plots in isolation. They install specialized nets along the edges of fields and irrigation channels. These are the fixed migration corridors that rodents traditionally utilize for movement. At first glance, the barriers look fragile, but they stand 60 to 80 centimeters high and are buried deep into the earth to prevent escape through digging. This creates a completely closed perimeter around the designated harvest zone. The decisive moment occurs when mechanical harvesters begin their operations in the field. As the rice is cut close to the ground, the natural shelter disappears, leaving the rodents exposed. The animals instinctively move along field embankments to find safety, only to run directly into the pre-installed net systems. It is visible how the metal and mesh structures channel the movement of the entire population toward capture points. 10,000 to 20,000 rats can be captured by a single team within just a few days during the peak season near Dongting Lake. When multiple villages execute these maneuvers simultaneously, the total number of captured rodents can reach several hundreds of thousands per harvest. It gets more complex further on. Financial costs are distributed among the households, but the mechanical effectiveness increases exponentially with the scale of the operation. Instead of targeting scattered individuals, the system impacts the entire local population at once. This significantly slows the recovery rate of the colony and reduces the probability of reinfestation from neighboring territories. The material remains secured and the agricultural cycle reaches the standard ready for the further stage. Thousands of wild field rats are removed from the ecological cycle of southern and central China as humans integrate these rodents into a local value chain. Why is it necessary to transform a pest into a commercial product instead of simply eliminating it? Complete eradication of the rat population remains an impossible task for agricultural regions, but by capturing and processing them, the local economy creates a controlled system that limits the damage to rice crops while providing a stable source of protein and income. Captured directly from vast rice fields, these animals are collected after extensive collective trapping campaigns that exclude any use of chemical poisons or toxic exposure. This ensures the raw material remains suitable for the next stages of the process. It only looks obvious that the meat is immediately ready for sale, but in reality, every animal undergoes a strict safety protocol at centralized facilities. One can notice how workers meticulously clean the carcasses and remove all internal organs to eliminate biological risks. The equipment gradually moves the meat through high-temperature chambers where it is fully cooked before it ever reaches a consumer. Preparation methods vary across regional markets to suit local tastes and demands. The meat is often prepared as roasted dishes over open flames, mushrooms, stir-fried with intense spices, or stewed for hours with traditional aromatic herbs. Everything only gets more complicated when calculating the economic impact of this trade. Dozens of yen per kilogram is the typical market price for this type of meat in rural centers. While it is not considered a premium or luxury product, the sheer volume creates a self-sustaining local market. During the peak periods immediately following the harvest season, the capture rate reaches several thousand individuals in a single district. The process is only gaining momentum as the additional revenue helps farmers offset their seasonal financial pressures. One can notice how the systematic removal of high-density colonies impacts the environment. When the population is harvested during its peak growth phase, the natural recovery rate of the species slows down significantly. This prevents the rapid explosive growth that leads to massive outbreaks during the subsequent crop season. Controlled consumption serves as a biological regulator for the agricultural landscape. The metal blades of the processing units continue to rotate and the prepared product moves toward the local stalls. This cycle allows for the stabilization of the fields while maintaining a traditional food resource. 20 to 30 rats are neutralized by a single terrier during a single working session on an active farm. Why do these regions reject the industrial integration of rodents into a value chain? While some territories choose to process these animals as a resource, the approach on the other side of the Pacific Ocean takes a different form. The struggle remains intense, yet it relies on biological instincts rather than mechanical processing. Agricultural and suburban zones across the United States, specifically within the borders of California, Texas, and Illinois, maintain traditional extermination protocols. They utilize specialized rat hunting dogs. Not every canine breed possesses the physiological requirements for this technical task. Terrier breeds, including the Jack Russell Terrier and the Rat Terrier, have undergone selective breeding for dozens of generations to optimize their performance in grain storage environments. These animals are characterized by small physical frames, high reactive speeds, and an extreme sensitivity to olfactory markers. One can notice how the dogs lower their heads, their nostrils twitching as they track scent trails across the dirt floor. It only looks obvious to set mechanical traps when a nest is identified beneath a hay pile or inside a barn, but in reality, farmers bypass hardware solutions in favor of releasing the dogs into the suspected zone. Within several minutes, the terriers identify the layout of underground tunnels and force the rodents into the open. The process is only gaining momentum as the dogs move with mechanical precision to subdue the targets on the spot. This biological method functions without the introduction of synthetic chemicals into the environment. No toxic residues remain in the soil, and the local food chain, including the livestock, remains entirely unaffected by pesticides. It is visible how the dogs work without the need for human intervention once the perimeter is established. But this is just the beginning of the application of this method. Organized groups in metropolitan centers like New York and Chicago have adapted these agricultural techniques for urban environments. They conduct controlled nighttime operations near waste disposal sites and within public parks. These hunts serve as a functional pest management system that simultaneously acts as a structured community activity. The dogs move through the shadows of the containers, their movements sharp and calculated as they clear the designated sectors. The task concludes with the removal of the pests, ensuring the area remains clean for the following day. This traditional cycle provides a sustainable alternative to chemical intervention across diverse landscapes. Thus, the management of the rodent population reaches a state of equilibrium through these specialized biological units. $11.4 billion is the staggering annual revenue generated by the rodent and pest control industry across the United States. Why do property owners invest such massive sums into specialized elimination teams? While standard methods exist, many farms, grain storage facilities, and abandoned industrial sites face infestations that exceed normal control capacities. In these scenarios, the situation transitions from a minor nuisance to a structural threat, requiring the intervention of professional contract hunters. These specialized teams do not operate randomly or without a calculated strategy. The process begins with a comprehensive survey of the designated area to identify primary nesting sites and the specific travel routes used by the rodent populations. At first glance, the task might seem like simple extermination, but in reality, it is a precise operation based on animal behavior and site logistics. Operations are strictly nocturnal to align with the peak activity of the targets. One can notice how the equipment remains silent during the initial setup as the team waits for the darkness to settle. In high-density environments like public landfills or decaying warehouses, a single professional team can eliminate between several dozen and 300 rats in one shift. It is visible how the technicians move methodically through the shadows, clearing sections of the property with high-intensity focus. The process is only gaining momentum as more hotspots are identified. In major cities like New York, the scale of the challenge increases significantly. Estimates have placed the rat population in the millions at various times, necessitating an annual rodent control budget that reaches $32 million US. This level of funding supports tens of thousands of service contracts within metropolitan centers. Everything only gets more complicated when considering the sheer volume of underground infrastructure and dense urban layouts. The objective extends beyond the immediate reduction of numbers to the preservation of public safety. Maintaining population density at a controlled level ensures that infrastructure, vehicles, and public health remain protected from biological and physical damage. Because rats are treated as a manageable variable within urban systems, the strategy remains proactive rather than reactive. Therefore, when density spikes in a specific sector, a rapid response is deployed to prevent the migration of the population into neighboring communities. One can notice the coordination between city management and private contractors as they isolate these zones. The focus remains on eliminating active hotspots and establishing a long-term balance in the ecosystem. Transition to the next level occurs as these interventions move from the center to the periphery of the urban environment. It only looks obvious to wait for a widespread outbreak, but the American model prioritizes early suppression. By treating the presence of rodents as a technical problem within the framework of municipal maintenance, the teams ensure that the impact on human activity remains minimal. Thus, the management of these urban variables continues as a quiet, constant effort to stabilize the environment. Tens of millions of dollars is the budget New York City allocates for pest control. Yet, not every community possesses such vast financial resources. Why do residents in small towns and suburban neighborhoods often reject expensive professional services in favor of alternative methods? It seems simple to hire a specialized team, but in reality, the high cost makes collective action nearly impossible for many. Small-scale homemade traps deployed on a wide scale offer a decentralized solution that bypasses the need for massive municipal funding. The cost of a single homemade trap typically ranges from $20 to $50 US, which represents a fraction of the expense required to hire a professional pest control team. Common varieties include spinning bucket traps, flip lid designs, and multi-catch mechanical systems that operate without complex electronics. One can notice how the simple mechanics of a weighted lid or a rotating cylinder allow these devices to reset themselves automatically after each activation. But this is just the beginning. The effectiveness of these systems is visible when they are placed precisely along active travel routes. Certain bucket trap models are capable of catching between 10 and 20 rats in a single night of operation. On farms across the Midwest, placing these units along warehouse walls and common rodent pathways can reduce population density by 30 to 50% within just a few weeks. These figures are supported by local agricultural extension reports that track long-term population trends in rural areas. One can notice that the true power of this method does not stem from the performance of a single device, but from the simultaneous deployment of many units across a territory. The process is only gaining momentum when the general principle of saturation is applied. Identifying movement corridors and placing traps continuously rather than sporadically ensures that the rodent population cannot easily bypass the perimeter. It gets more complex further on. Daily inspections are required to maintain the functionality of the mechanical components and to clear the catch. When this strategy is implemented across dozens of households within the same geographic area, the low individual cost produces a significant combined impact on the local ecosystem. The equipment gradually wears down the population through sheer numbers and persistence. Transition to the next level. Mechanical traps leave no chemical residue in the environment, which distinguishes them sharply from the use of traditional rodenticides. This lack of toxicity reduces the secondary poisoning risk to household pets and valuable livestock roaming the farm. For this reason, in many small-scale agricultural regions in the United States, these homemade systems remain the primary line of defense. They are flexible, inexpensive, and easily scaled to meet the specific needs of a local community. The material remains a reliable standard for those managing land and property without the intervention of large-scale corporate services. Thus ends one of the key stages of localized pest management. 25,000 is the approximate number of individual rodents inhabiting a single religious complex in the state of Rajasthan. Why does this specific location maintain such a dense population of animals usually classified as pests? While much of the world implements rigorous extermination protocols, the Karni Mata temple operates under a completely different cultural logic, where these creatures, known locally as Kabbas, are systematically protected. This environment represents a unique sanctuary where the rodents are not only tolerated, but are actively fed and shielded from any external threats. One can notice how visitors entering the temple grounds must remove their footwear, ensuring that every step taken on the stone floor is careful and deliberate. It is visible how the crowds move slowly to avoid physical contact with the animals scurrying between their feet. This relationship is deeply rooted in local traditions that view the presence of the rodents as a sacred element of the architecture and history of the site. Everything only gets more complicated when this localized reverence is compared to the national agricultural landscape. 130 million tons is the massive volume of rice produced across India every single year. But this high productivity exists alongside a significant economic reality involving the same species found in the temples. It seems simple to manage a single site, but in reality, the scale of the challenge changes drastically when applied to the nation's food supply. Agricultural authorities report that between 5 and 10% of the total output in several states is lost due to rodent activity annually. These losses translate into millions of tons of grain that never reach human consumption. $2 billion represents the estimated financial impact of these losses on the national economy, according to official calculations. The process is only gaining momentum as urbanization continues to alter the habitats of these rodents. In many neighborhoods, the population density reaches over 20,000 people per square kilometer, forcing humans and animals into constant involuntary proximity. One can notice the shared use of drainage systems and the common competition for discarded food sources in these tightly packed urban environments. But this is just the beginning of the complex interaction between the species. The environment is neither a state of total conflict nor one of absolute harmony, but rather a constant negotiation of space and resources. Each geographic region and cultural group selects a different strategy to address the presence of these animals, ranging from spiritual protection to large-scale agricultural defense. Transition to the next level. These localized choices ultimately dictate the global methods used to control or integrate this species into the human world. The material situation remains a reflection of these diverging priorities and environmental pressures. Thus ends one of the key stages of understanding the global distribution of the species. 100% of the success in managing large-scale biological populations depends not on the volume of the catch, but on the systematic alteration of the environment by human intervention. Why does the displacement of these rodents occur with such mechanical predictability during the harvest? At first glance, the sudden movement of thousands of animals seems like a chaotic flight, but in reality, it is a forced migration into a pre-existing perimeter of control. The removal of surface cover by heavy harvesters eliminates every available shelter in a matter of hours. But this is just the beginning. The ecological balance shifts not through chance, but through the execution of a strictly coordinated technical strategy. One can notice how the rodents are driven towards specific zones where the infrastructure for containment has been established long before the first machine entered the field. Scale and timing determine the final outcome of this industrial-scale confrontation. It is visible how the response speed of the containment system functions as a counterweight to the rapid natural reproduction cycle of the species. The equipment gradually narrows the operational space, ensuring that the biological pressure is neutralized through calculated spatial management. The process is only gaining momentum. Everything only gets more complicated as the transition to the final stage of the territorial clearing is completed. Therefore, every movement of the machinery is synchronized with the known behavioral patterns of the target population to ensure maximum efficiency. The narrative of this interaction is defined by the technical superiority of the response rather than the simple tally of the results. This stage of the environmental management process concludes, leaving the landscape prepared for the next cycle of production.